Nuclear reactor. The nucleus of an atom is held together with great force, the strongest force of nature. When bombarded with a neutron, it can be split apart, a process called fission. Because uranium atoms are so large, the atomic force that binds it together is relatively weak, making uranium good for fission. The nucleus of the uranium, or U-235 atom, comprised of 92 protons and 143 neutrons. When the nucleus of a uranium atom captures a moving neutron, it splits in two and releases some energy in the form of heat. Also, two or three additional neutrons are thrown off. If enough of these expelled neutrons, a fission chain reactor may be achieved. When this happens repeatedly, many millions of times, a very large amount of heat is produced from a relatively small amount of uranium. It is this process, and in fact burning uranium, which occurs in a nuclear reactor. The heat is used to make steam to produce electricity. In a nuclear power plant, neutrons collide with uranium atoms, splitting them apart as vast as the ocean. This will release neutrons from the uranium that in turn collide with the other atoms, causing a chain reactor like a domino effect. The chain reaction will later be controlled with control rods, which absorbs neutrons, and which can be inserted or withdrawn to set the reactor at the required power level. In the core of nuclear reactors, the first fission of uranium atoms will release energy that heats water to about 520 degrees Fahrenheit, as hot as magma. This hot water will then be used to spin turbines that are connected to generators producing electricity. The heat created by splitting the atom, the U-235 atoms or uranium, is then used to make steam, which spins a turbine to drive a generator producing electricity. The fuel elements are surrounded by a substance called a moderator to slow the speed that was as fast as a car, now as fast as a horse. Speed up the emitted neutrons and thus enable the chain reaction to continue. Water, graphite, and heavy water are used as moderators in different types of reactors because of the kind of fuel used. If there is a major uncorrected malfunction in a reactor, the fuel may overheat and melt, but it cannot explode like a bomb. A typical 1000 megawatt reactor can provide enough electricity for a modern city of up to 1 million people.